everyone, welcome all of you in my YouTube channel. I am MD Mehboob Hussain and today we will discuss graph theory. Okay, what is the basic concepts of graph theory like degree, loop, parallel edges, simple graph. What is the definition of this type of uh, graphs? Okay, that means fundamental concepts of graph. Okay, so let's start. So, first of all, we must have to know what is a graph. Okay, actually, graph theory is the part of discrete mathematics. Okay, actually, how can we lay or cable at minimum cost to make every telephone reachable from every other? And these are the practical examples why we read graph theory. Actually, what is a graph? Okay, the suppose what is the farthest fastest route from national capital to each state capital, or in what order should a traveling salesman visit cities to minimize travel time, or can we color the regions of every map using four colors so that neighboring regions receive different colors. These and many other practical problems involved in graph theory. Okay, so uh, what is graph? What is the definition of graph? Okay, see, uh, a graph. See, 1 minute. A graph generally we denote it as capital G. G equal to V comma E. Actually, the graph consists of two sets, this V and E, two sets, non-empty sets V and C, V and E, and where V is called vertex. Okay, vertex set. V is the vertex set, and E is a edge, which is a subset of V cross V. Okay, it's called E is the set of edges, set of edges. Okay, so if E equal to A comma B belongs to the edge set capital E, then we say that edge, then we say that the edge E equal to AB has and vertices A and B. Okay, and vertices A and B. Okay, so that is we say that E is incident to and A and B are adjacent. Okay, A and B are adjacent. Now, if we take an example, if we take a practical example, see this graph. Okay, if we take this, okay, this is a graph where vertices are also called nodes. Okay, these are the vertices. So here in this graph, four vertices or four nodes here, V1, V2, V3 and V4. And what are the edges here? This V1, V2, this one E1, V2, V4, this is E2, V3, V4, E3 and V1, V3. That means E4. So there are 4 edges and 4 vertices here. Okay. This is generally denoted by G. Okay. So in this graph, here in this graph, V equal to 4 and E equal to 4. Okay. That is V contains V1, V2, V3, V4 and edge set E contain E1, E2, E3, E4. So this is vertex set of this graph and this is edge set of this graph. Okay. So number of vertices of this graph is 4 and number of edges of this graph is also 4. Okay. So actually graphs are a way to formally represent a network. Okay. Formally represent a network. Okay. Or a collection of interconnected objects. Okay. Actually graph relationship represents a relationship. Okay. There are various types of vertices. Okay. Relationship between vertices and edges. Okay. So this is the basic definition or uh, fundamental concept of graph. Okay. Now we have to define degree of the vertex. Okay. These are also graph examples of graph. Okay. Here vertex is this, this and this. Okay. So here V1, V2 and V3. Okay. So here vertex set contains 3. That means number of vertices here 3 and number of edges also 3. Here this is also a graph where uh, 1 minute, sorry. This is also a graph where number of vertices is 4. Okay, number of vertices is 4 and number of edges also 4. But these two are quite different. Okay, here G1 and suppose this is G2 and G1 and G2 are quite different. But vertices, number of vertices and edges both are same. Okay, so now we define what is degree of the vertex. Degree of vertex. Okay, degree of vertex. See, the number of edges number of edges. So see, the number of edges incident to a vertex is known as the degree of the vertex. Okay, number of edges incident to a vertex is known as the degree of the vertex. Okay, degree of the vertex, and it is denoted by dv or degree of v. Okay, now see the understand this by example. Okay, in the previous example we, okay, this is a graph, and this is v1, v2, v3 and v4. Okay, and suppose these also are edges. Okay, so here number of edges, see the definition. The number of edges incident to a vertex is known as the degree of the vertex. That means vertex, each vertex contains, each vertex is connected to uh, which number of edges. Okay, the degree of the vertex, that number of edges which are incident to a uh, is the number of is the degree. Okay, so here see in v1, 1, 2 and 3 vertex are incident in v1. Okay, three vertex, three edges are incident to the vertex v1. So the number of, so the degree is the degree of the vertex v1 is 3. In this graph, suppose this is g. Okay, so in this graph, degree of v1, degree of vertex v1 is 3 because three edges are connected with the vertex v1. Okay, that is uh, three vertices are adjacent, three edges are adjacent with the vertex v1. That's why the degree of v1 is 3. Also similarly, here see, uh, first of all we named each edges e1, e2, e1, e2, e3, e4, this is e5 and this is e6. Okay, sorry, sorry. uh, so here we named every edges e1, e2, e3, e4, e5 and e6. Okay, there are 6 edges here and there are 4 vertices v1, v2, v3 and v4, 4 vertices, and degree of v1 is 3 because e1, e4 and e5 are connected or adjacent or incident to v1. That's why the degree of v1 is 3. And similarly v2, degree of degree of v2 is also 3 because 3 edges are connected with v2, vertex v2. Okay, that's why e1, e2 and e5 are uh, adjacent or incident or connected, you can say. Okay, that's why the degree of the vertex v2 is 3. And similarly degree of v4 is 3, degree of uh, v3 is 3. So this is a three regular graph. We will discuss a regular graph in the later video. Okay, what is regular graph? Actually, regular graph is if in a graph every vertex have same degree, then we say the graph is regular. Okay, and here you can see here v1, v2, v3 and v4 all vertices are same degree 3. That's why this graph is three regular graph. Okay, so I hope you all are understand the degree of the vertex in a graph. Okay, now uh, we discuss we discuss uh, what is the parallel edge. Okay, actually what is parallel edge? Okay, we erase this. um, degree of P1 is 3. Now, parallel edge. Parallel edge in a graph. Okay, what edge a parallel is? Edge between same pair of vertices. First, in this graph, you can see in this graph, these are the nodes. Okay, these are the nodes, and parallel edge means this type. Okay, if in a graph use this type of edges you see, then this graph is this graph has parallel edges. Okay, or you can also draw this. Okay, so this is not a simple graph. Okay, this graph has parallel edges because this type of edges, if any graph have this type of edges, then that graph is called parallel edge. Like here also, this, this, and this. Okay, so suppose this is G1 and this is G2. Here 1, 2, 3, 4, 1, 2, 3. So number of vertices here, number of nodes here 4, and in G2 number of nodes is 3, number of vertices is 3, and what are the edges here? See, E1, E2, E3, E4, E5, and E6. So in this graph there are 6 edges have. Okay, and these are the parallel edges. Okay, these are the parallel edges. These are the parallel edges. Okay, in this graph these are the parallel edges. Okay, so now we write the definition of parallel edge. Okay, edges edges between same pair of vertices. Same pair of vertices are known as parallel edges. Okay, parallel edges. Edges between same pair of vertices. Okay, are called parallel edge. See here, E1 E1 is connected with the vertex 1 and 2. Okay, and also E2 is the edge E2 also connected with the vertex 1 and 2, between the vertex 1 and 2. That's why here definition, edges between same pair of vertices are known as parallel edges. Okay, now what is node? Okay, what is node? In the next slide we discuss node. Okay, node in a graph. What is node? Sorry, node, not node, actually loop. Sorry, loop. What is loop in a graph? What is loop? Okay, see, we understand this by graph. Okay, by taking an example, this. Okay, here vertex v1, v2 and v3. Suppose this is vertex 1. Okay, 1, 2 and 3. So if any vertex have this type of edges, this is also a edge. Okay, this is also edge. Okay, this is also edge. Okay, where starting and ending vertex of this edge are same. Okay, that's why it is called loop. Okay, loop means starting and ending vertex. Here see, if we start these edges, here is start from 1 and also end 1. But in this edges, start from 3 and end, and starting vertex 3 and ending vertex 1. Starting vertex 1, if we start from here, starting vertex is 1 and ending vertex is 2. Okay, so in this edge, E1, there are different vertices, but this, if we named this edge is 2 E2, then this edge E2 starting and ending vertex are same. This is called loop. Okay, so this graph G have a 3 loops. Okay, and you must have to know, we discussed the degree of a vertex. So actually, degree of this type of vertex, this type of graph, if any graph have loop, okay, then uh, degree of that graph, degree of degree of vertex 1 here, uh, number of edges incident to 1, number of edges incident to 1. So there are 1, 2 and 3. So but for node you can add 2. Okay, there, so here number of edges 1, 2, so 2 and plus for node you will add 2. So the degree of vertex 1 is 4. Here every vertex, here also degree of 2 is 4, degree of 3 is 4. If we draw the graph this, and if only the vertex 1 have loop, okay, and no other vertices have a loop, 2 and 3 don't have a loop, do not have loop, then a degree of 2, degree of vertex 2 is only 2 because 2 vertices are adjacent, and degree of 3 is also 2. Okay, but degree of vertex 1 here 4 because 1, 2 and this edge, because starting and ending vertex are same here. So we add up degree of vertex 1 is 4. Okay, for loop we add a degree 2. Okay, for loop any vertex, if this is a vertex, this is a vertex and isolated vertex this, and if this vertex have a loop, then this vertex are degree 2. Okay, I hope you understand now. So what is loop? Definition of loop: if both end, uh, if both end both end vertices, if both end vertices edge of an edge be same, okay, then that edge is called, that edge is called self loop or loop, self loop or loop. Okay, if this is a graph, okay, suppose this is a graph, and also here the loop is here. Okay, So I hope this is called loop, where this is vertex v1 and this is loop. Okay, this is loop. Now, what is simple graph? What is simple graph? See, simple graph, a graph without a self loop, and parallel edges. Parallel edge without. Okay, a graph without self loop and parallel edges is called simple graph. Okay, a graph without self loop and parallel edges is called simple graph. Like this. Okay, this graph doesn't have parallel edges or loop. This or this, or you can write this. Okay, these graphs are not have loops or parallel edges. This is called simple graph. Okay, and also we must have to know what is pendant vertex. Okay, or isolated vertex. Isolated vertex means if any graph, suppose this is a graph and here one more vertex here, v1, v2, v3, and this is v4. This is v1, v2, okay, and this is v4. Okay, so here isolated vertex is v4. No edges are connected or no vertex are adjacent with this vertex. Okay, or you can say the degree of the vertex is 0. It's called a isolated vertex. If a vertex of degree 0, then that vertex is called isolated vertex. If so, you can see here the vertex v4 does not have any edges that are connected with v4. That's why the degree of v4 is 0. Okay, degree of v4 is 0, so this is isolated vertex. So a vertex a vertex of degree 0 is called isolated vertex. Now, what is pendant vertex? Pendant vertex. What is pendant vertex? A vertex of degree 1 is called pendant vertex. Here you can see V2 is pendant vertex because the only one edges are connected with the vertex. Okay, here V3 is pendant vertex because only one edge are connected. Okay, this is also a graph where V1 and V2 are the vertex and only one edge are here. So these two vertices are pendant vertex because the degree of V1 is 1 and degree of V2 are 1. Here degree of V2 is 1, degree of V3 is 1. That's why V2 and V3 are pendant vertex. Here in this graph, V3 and V1 or V2 are pendant vertex. Also, you can see if we if I draw this, okay. So here you can see this and this vertex are pendant vertex. Okay, pendant vertex. This is pendant vertex. The degree of this vertex V1 is degree of this vertex V1 is 1 and degree of this V2 vertex is 1. So what is the definition of pendant vertex? A vertex of degree 1 is called pendant vertex. Okay, that's all today. So thank you. If you understand my video, if you like the concept of way of uh, understand my every topic of graph theory, okay, then please like, share and subscribe my channel. So thank you, and please subscribe my channel.